week 4 content. Anyhow, since today only it is released, I give some summary about that. What are the things to be considered, and what is the benefit of? I mean, how it is useful for the simplification. Basically, you're looking for simplification of your Boolean logic gates. I mean, if you have very big expression, our task is to reduce your simplification. I mean, we want to simplify the circuit. What is the role of? I mean, what is the significance of simplifying circuit? Can you give some idea? Put your answer in the chat box. I mean, chat message. Your answer. What is the advantage of simplifying your circuit? Why we are simplifying? What is the role for simplification? That's why it makes to interest to learn these particular things like simplification algorithm. Yes, number of logic gates. Great. Why we need less number of? Okay. Other than any other answer? Please feel to put your answer. No problem. Whether it is a wrong or right, it's not a problem. Type your comment on your chat message. So I'm just write a question here so that maybe those who are newly joined can also able to answer this one. So why simplification in Boolean logic? Boolean expression. Okay, why? So one answer is less number of logic gates. Okay, I just create one code. Okay, I just mentioned that. I mean, can you please go and look the polls which is active right now? So have you put a high speed operation? Only 4 guys are given. Others, can you give some your opinion? So actually, this purpose is all them because we want a compact. Because the product side, if you think about it, we always expect the compact size. And if we want a compact size, we should not need more number of logic gates. But I need same functionality. So you have to do the same functionality with some other relevant circuit items to be add on or something to be put it up. So that what happened, we get the very less area occupation of your logic gates. So the number of logic gates, if I reduce it and that perform the same operation, right? If it's so, then it is very good. So that is what one of the important thing like compact IC design. And if you have less number of components, of course, what happens? The power consumption will be very less. Right? Number of transistors will be reduced. And finally, if the number of components are reduced and all the components having very less propagation delay, and I hope you will study about what you mean by propagation delay in the future course or in the future weeks of digital system itself. If sometimes some kind of delay is there. If you are, for example, if I give logic 1 to my inverter, say for example inverter or NAND gate or any gate, okay, if I give logic 0, it is supposed to give logic 1, but not at that same instant of time. There must be small fractional delay will be there. So if I had more number of logic gates, yeah, please, Atharva Dhananji.
Yes, sir. Pardon, sir, but there is somewhat noise in your voice, so that's why I've raised the hand.
Oh.
Can you
Please
adjust my
edify
mic?
that now? Is it okay? It's
Can you
better
speak
or
up?
still?
Yeah, it's better now.
Yeah.
It's
Yeah, I
better.
think it's a fan noise.
Yeah, now it's better.
Okay. Well, I think we are discussing about the compact IC based and low power design, and then finally we come to the next part is due to propagation delay. Okay, one IC is having some propagation delay. So what happened? The actual output comes after the, not at the same instant, maybe at this after some instant. If I have the chain of ICs, chain of logic gates, what happened? The propagation delay keep on adding up. If it's so, what happens? I can't able to perform fast operation because of delay factor. If I have less number of IC along with that prime propagation delay, but number of ICs number of gates are reduced, right? Finally, what happens? I can able to increase the speed. I can able to for high speed operations. So the main purpose is that we are expecting to simplify your circuit. At the one side of application is I want high speed operation. And the other side of application is compactness. And combination of both the things, if I did so, low power consumption. That's it. So low power design is another side. These are the things we have doing so. So finally, what is the conclusion? Simplification is the only method. We don't want to keep every elements as it is. So if I have some variables, like say for example, like variable, maybe I can define numerical numbers. We have to go into discuss with numerical numbers. So let's say some decimal number like 0, 1, 2, 3, 4, 5, 6, and so let's take 7 numbers. Okay. If I want to represent this number, since I have the 7 numbers, I suppose to need at least 3 numbers. At least I need 3 bits. So the maximum number is 111 and minimum number is 000. So I need to represent by 3 bits of representation. Is it so? No. It is one of the simplest way of representing. I can able to represent the same 0 like this way also. This again give the same answer. Okay. Is it fine? If I represent in 8-bit also, it is okay. Okay. So which is convenient? Minimum bit or maximum bit?
Minimum bit.
Yeah, but we come to the other area of part. So now next part is I just raised this particular point, and we will discuss about it in detail later. So the point is that I am just telling you that I can able to represent the same number in many ways. One is in 3-bit, and another way is n number of bit. Okay, so this I can define with I can change the state with the inputs. Like I can able to tell that this is a variable is used some input line A line and B line and C line. If A line is 0 and B line 0, C line 0, it is giving the input called 0, 0, 0. If A line is 1, B line is 0 and C line is 0, then it is I'm feeding the input called 4. Concatenate of all 3 different input line as a single binary number. As like I can able to concatenate and make it to execute with your device. It means that I have my black box device, which is it has some internal combination of logic gates, and it is need to provide some. It has to produce output 1 or output 0, some output line. Okay, and this output line will be asserted because of providing some input. Okay, and if I want to operate this particular block box from 0 to some range, so it will operate only from 0 to 7. That is enough with 3 number of input lines. That's what I'm telling you. So 0, 0, 0, it refers to it refers to 0 line. Or if I giving 0, 0, 1, it refers to input line 1. 0, 1, 0, it refers to 1 or 2. Like this, it will keep on referring. And how do I represent in the expression base means wherever there is a 0, I supposed to mention it as a complement operation. So point is that I supposed to provide input A. So if suppose I want to produce output, what are the dependent variable of output Z? A, B, C. Either A is also only A is dependent, or B is only dependent, or C is dependent, or all the things are dependent.
All the things are dependent.
So A and I want to do B also. So A and B and C in some combination. Okay. So how can I represent this 0, 0, 0 in binary number of decimal number 0 in binary format with the help of external user input of 3 separate lines like A bar dot B bar dot C bar. It means I supposed to give A, B and C to the 3 input AND gate. It gives output. It is work. This particular AND gate is working. If the input number is 0, it gives output 1. Am I right? If I'm feeding 0, 0, 0, outputs are of this is 1, and all 3 inputs of the AND gate is 1. So final output is 1. Is it fine? Okay.
Yes,
Similarly,
sir.
like this I can able to write A dot B bar dot C bar. Similarly, all ones can be represented as uncomplemented value of that. So wherever there is 0, I supposed to put bar and AND gate. So this way is called as minterm. Okay, and I can able to define this minterm with some notation or product terms. Simply I call it as product term. I can define this product term, which is some way as like small m0 and 1, which is nothing but A bar B bar C, which is equal to m1, A bar B dot C bar, which refers to m2, A bar BC, m3, m4. Okay, and finally it is m7. Similarly, we can have m5 and m6. Is it okay?
Yes, sir.
So next point is I'm telling you minterm m0. What is the equivalent decimal value of what will be the way of how many bits of numbers is required? Okay, or else I just put a poll on here. You just tell me the answer. Which is the exact equivalent minterm of value 0? Okay, some guys have mentioned with the 2 A bar, B bar, C bar, and some say only one guy is mentioned is insufficient info. So only one guy is defined insufficient. Can you please unmute and tell me why you're telling it is insufficient info? Okay, fine. I think we can go ahead with it. Can you please tell me what is it? What will be the right answer? Insufficient info, or A bar, B bar, C bar, or A bar, B bar, C bar, D bar, or N input NOR gate? What is 0, 0, 0, 0, 0? Some number of zeros. It is equal to decimal value of
0.
right. I can represent this with A bar, B bar, C bar, D bar, E bar, F bar. Am I right? If I have this number of input line,
Yes, sir.
and this is equal to what? A plus B plus C plus D plus E plus F the whole bar. Is it okay as per Deepark's law?
Yes, sir.
If I have n input line, I can have n number of OR gate.
Yes, sir.
Yeah. So this actually, I can say that this is insufficient information only. I mean, not so, because min term I told. If I mention only 0 means 0 can be either M0 or M0. This is a max term representation. This is a min term representation. This is capital M0. This is small m0. Okay. So let us take some min terms. I have, so let me refer like this. Let's say I have the function of m0 plus m1 plus m3 plus m4. What is this m0 will be? And I mentioned f of a comma b comma c. It means this is a function of 3 input variable. So m0 will be
A bar, B bar, C bar.
exactly, plus m1 will be a bar b bar c plus a bar b c. Sorry.
And A bar BC.
Yeah, last one. Yeah, a bar bc. So what is the simplified expression?
What's the
That
third
one I think A B bar C bar, sir.
A, B bar, C bar.
Yeah, A B bar C
No.
bar. M4, sir.
No, you are telling the finalmost answer. Am I right?
No, sir.
Sir,
The last midterm.
you written M4 equal to A bar.
Sorry. Yeah. Sorry. Thanks for giving this word. 3 is valuable, right? Okay. Well, so in this case, how can I able to simplify it? So I can compare these two number. Is these two min terms are having single bit value changes?
Yes, sir. B bar, C bar.
Multi-bit. Okay, B bar, C bar, and A is single bit value. So I can tell A bar, B bar, C bar, and or something, and A, B bar, C bar are adjacent cell. If they are adjacent cell, there is a chance for reduction of number of bits. So if it is 4 cells, some number of cells, some number of little may be reduced. So if it's so, I can simply, this term is equal to B bar C bar times of A bar plus A, which is equal to B bar C bar from these two terms. Am I right?
Yes, sir.
And compare these two things. How many bits are varying? A bar, B bar, C, or A bar, B, C. I can take A bar, C common, then B plus B bar, B bar plus B. That gives A bar plus C. Am I right?
Yes, sir.
Yes, sir.
Yes, sir.
So we can simply, this above expression can be, first of all, I think, can I erase this part because we already discussed? Is it okay, right? Shall we erase this part and
Yes,
I'll
yes, sir.
directly write this? Yeah. I simply rearrange like this: A bar, B bar, C bar, or this term A, B bar, C bar, or these two terms like A bar, B bar, C plus A bar, B, C. Okay. So this gives what? B bar, C bar common term. This gives A bar, C common term. Is there any further reduction will be happen? Is there any chance of further reduction? Yeah, is this came up? Yeah, this is a fundamental part of came up. In the next week only we start studying about the Karnaugh map. When before quiz 1, we will release that week for a content. So please practice Karnaugh map very effectively. My suggestion only, it's your wish. But what is the advantage of Karnaugh map means we can simplify your each and every canonical representation very fastly. Yes. Can you please mute? Yeah. Yes, Nikhil Behal.
Sir, I have a question related to grade assignment 3.
Okay. The deadline is over.
No,
I
sir.
think
No, sir.
yeah.
Deadline.
Maybe that
What?
you should not ask the related. You just try to ask without policy. You just try to ask. I don't try to give the solution, but maybe I can try to. What is the difficulty you face? You just tell the difficulty.
Sir, I got in the first question, I get two of the options are correct according to me.
Sir, in second question also, sir, I got 3 options are correct, but only one option have to choose.
So it is basically it's a controversy question like something.
Okay, we will find out the statement. I mean, we will discuss first two question, right? I will just check it up. If it is so, I can modify it, or else we can discuss in the next class because I supposed to check again.
Option second and fourth is a correct answer.
No. Don't say no way of answering this right now.
Okay. Sorry, sir. Sorry.
Yeah.
Sir, I also had a issue.
No, I mean, instead of telling the answer, if you face any difficulty, you can ask me.
Okay, sir.
Why not multiple choice of chance means we can change that way. Your wish, you can select whichever you want. But actual right answer only gets a point.
First question is single correct answer. Question type.
We will just check that on later point. I think we solved also. I think it's not too problematic. Slowly discuss. I mean, try to reevaluate yourself, and you can get the exact answer.
Sure, sir.
Yeah. Okay.
Sir, I also have an issue.
But sir,
Yeah.
sorry
Yes.
for interrupting. But sir, like we got two answers correct. If the more accurate answer is like something option, we don't know, and we take the other correct answer. So basically, marks, is this correct or not?
No. You'll have. That's why I'm telling you. If it is having only one choice is the right answer, means that is seems to be that some other also seems to be equivalent to a right answer. But when you look at with the laws of Boolean, when you apply the Boolean law, you can understand which one is the right answer. So we are trying not to give the answer. We are trying to apply your laws which you have learned. Please apply that law. Instead of, I'm not sure about in what way you are identify the answer, whether you are did by trial or the truth table of all the 8 combination cases and finally answer. That's not what we are expected. We are expected to apply with the Boolean laws and the
Yes, sir.
DeMorgan laws and so on.
I applied Boolean algebra, sir.
I also
Then I
Yeah,
got 3
maybe
options are correct.
Boolean laws and all that, and I tried.
okay. I'll just verify that one. I'll just check and verify and revert you back. If it's wrong means from our side, I can remove from evaluation. No problem.
Okay, sir. Okay, sir.
Yeah.
Thank you, sir.
Sir, I uploaded all the handwritten solutions for week 1 and week 2. Still, I got an email like I didn't have uploaded them.
It is okay. Specifically, mentioning your name and comes or general message.
What?
But
Is
in
it general message or
I don't
mentioning
know
your
about
name?
that. No, I don't know about that. But the email told me that I haven't yet submitted it, but I already did.
Okay. No problem. We will just verify, and if you have any, you just put your mail ID here. We'll check that one.
Okay,
Okay.
sir.
in my dashboard, there is no option to upload any PDF
No,
like
I
that.
just mentioned in the G chat, right? I mean, I hope you guys are.
No, sir, I think
You can
the
use this
PDF
one.
link. The PDF
Yeah.
link is on the week 1. Week 1.
Yeah, that link is use the same link. You
Yeah.
can access we can change your week content, which week you want
Yes,
to
yes.
suppose to upload. I think I asked the thing to put into the outside page of portal instead of putting in the graded assignment.
Okay, okay, sir.
Okay, then this problem may be solved. This is a general statement to feed the solutions, right? That's why I'll just change that one. Okay, so if in this case, can you tell me how many AND gate, OR gates, NOT gates are required?
2 AND gate, 1 OR gate.
And NOT gates?
Not gate, 2 NOT gate also. To in what
No,
then?
3 because A bar is also there, right?
Oh, 3 NOT gate, 2 AND gate, and 1 OR gate.
Okay, this is your statement. Is it any possible further way to simplify this? Let's check that one. Okay, we know the distributor, right? Distributor law. So if I have the expression like this,
Yeah, sir. We can use NAND gate instead of 2 AND gate and
yeah,
always we can
okay,
NAND
fine.
gate.
Universal gate is okay. Universal gate is makes to simplify this much better than that. I'll try to give in another try. Let me try whether I'm getting higher number of gates or lower number of gates. If this is in sum of product, minimized sum of product, or simplified form of sum of product. Simplified form of or normal method of sum of product. I'm just trying to do the same process with product of sum. By distributed law, how can you write it up? It is A bar plus B bar, A bar
plus C
plus
bar.
C bar, then B bar plus C, then C bar plus C is C1, so it is cancelled. So here I need A bar, B bar, C bar, so NOT gate is 3 NOT gates. AND gate, OR gate is 2 input OR gate, I need 3, and 3 input, 3 numbers of 2 input OR gate is 3, and 3 input AND gate is 1. Somewhat complicated in size. Right?
Yes.
So if I in this expression I'm getting the simplified form of POS is overloaded or required more number of ICs compared to SOP. It's not the same case for all the times. There is a chance for reducing in a POS format compared to SOP format. We may see such a kind of expression in the following courses. Okay, even in the term course of also.
Sir, how did you apply the distributive law for B bar, C bar plus A bar, C? Can you please?
Okay, yeah. So B bar, C bar plus A bar, C. Let us assume this particular element is equal to X. Okay, if it's so, we can simply write as B bar plus X times of C bar plus X. Then A bar, substitute that X value. Again, the same process. B bar plus A bar. Yeah. Okay, well, so this is another time for telling you, asking some more question. Yeah, your idea. What are the adjacent terms of these 3 bin terms? I think answer. I think I was wrong. Multiple select is forgot to show.
Sir, can you repeat the question again, sir?
Yeah. 1 second. Repeat the response. This is in the poll. Okay. Let me recreate the same poll because I was wrong to term right. What are the adjacent cells of the given terms? M1, M0, M4, or M5, M2. Okay, and I think there is no option for multiple selection. No option, I think so. Okay, I think I was wrong. Okay, maybe I can edit this term. Okay, which one is not an adjacent element in the pole?
Sir, A bar, B bar, C bar, and A, B bar, C bar, they are adjacent. And even that is adjacent to A bar, B bar, C because only one bit is changed.
Okay, so M0, M2, M5, which are adjacent? Which are not adjacent? I mean, I think you are to see in the polling, in the poll at Google Meet.
Okay.
Which are not adjacent, I'm asking. I think nobody is polling.
Sorry, sir, but
Not-
I didn't get what adjacent mean in term of M0, M2, and M4.
Okay, so this is, I have 5 number of, I mean, maximum min term here is 5. Am I right? So you can represent with minimum number of input variable like A, B, C. So if it's so, here this M0 will be A bar, B bar, C bar, and M2 will be A bar, B, C bar, and M5 is A, B bar, C bar.
Yes, sir.
Right? In this case, is these two are adjacent with 1 bit variation?
Yes,
Sir,
sir.
Yes.
B, C,
This two,
A, B or C.
this, yes, these two are adjacent, right? Let's
Yes, sir.
compare with this is adjacent. Is these two are adjacent?
Yes, sir. Only 1 bit
I think I was
variation.
wrong. Yeah, sorry. This is 5.
Yes, sir.
I
No.
mentioned wrongly. This is not so. So one process is over. Now let's check these two things because I already compared this with this in different
Yes,
ways
sir.
previously.
Yeah. The M2 and M5 are adjacent.
So this is not adjacent. This is not adjacent only with this case. So this is only the non-grouping element. These are called as a prime implicant, essential prime implicant.
But
This I
in
called as a, yeah.
M2 and M5 there is only 1 bit variation, B and B bar.
No, A bar, B bar, C bar. Sorry, A, B bar, C bar. A, B bar, C.
Okay, sir.
So
I
here
got
this
it,
bit
got
is
it.
also varying. This bit, so
Yes,
totally 3
bit
bits are
variation.
varying.
Yes, sir. Got it, sir.
So this is not at all adjacent.
Thank you, sir.
Okay, and hence I can tell this is very essential element. I suppose to use this element without any compromise. Whereas these two element, okay, I can able to reduce it and write it up. No issue at all. What is the reduced simplified expression here for this case? From these two grouped element, A bar and C bar. Am I right? Because B gets cancelled. B's don't care here.
Yes.
Okay, and finally I can write this expression as, let me have this as a function of, okay, 0 comma 2 comma 5. If I mention like this is equal to A bar C bar or A B bar C. These are the two, this is a simplified expression for it. Okay, and what form I have used is, I have used one product term, another product term, so it is the sum of, or else sum of products, product terms, because this is one product term, this is another product term, and all the product terms are summing here. Sum in the sense not addition, ORing, that is what I am talking about. This is your OR operation. So we can internally tell it is a sum. Is it okay? Okay. Well, so I got this as some. I can alternatively write the same expression as a bar b bar c bar plus a bar b c bar plus a b bar c, which is entire elements I'm using. There is no change. There is no missing of element like b and b term. In this case, all the product terms have all the input variables. Okay, so it is called a same sum of products, sum of product terms in canonical representation or canonical form. So canonical form means I supposed to write with all the terms. Okay.
Okay, sir. Got it.
Let me come back to the same expression. Let me choose the same example, a bar c bar. I'm giving this as an example for you. We know that already this is a canonical representation. Now I want to emphasize this all the terms in canonical simplified form to canonical form. Okay, so here I have all three variables, but here b variable is missing. So what's supposed to do is a bar c bar, okay, times of some multiplication of something and this one. Well, one dot of anything is
C
one
plus
dot of
B plus D
same
bar.
term, right?
Yeah.
Right. So this one can be replaced by b plus b bar. If I'm doing one, I'm multiplying with any product term. That for what case I have used for, that should be done in the form of b plus b bar, which gives one only.
Yes, sir. Yes, sir. Got it.
Okay, hence I can expand it with the help of distributed law. It is nothing but a bar b c bar plus a bar b bar c bar plus like this. Is it okay?
Yes, sir.
So now let me take under product sum terms. I think I have chosen this number, right? Okay, can you please write the same above expression? Okay, let's take f equal to AC. Is it AC, right? Yeah, it is a bar c bar plus a b c bar. So how can I write in the form of max term? Okay, so before that, I am supposed to tell you what is max term. Let me go back to the same here. Okay, I'll just write here onwards. So let's take with three variables. Then that is applicable for all the cases. Just increase your understanding. Okay, so normally min terms mi or mi refers to 0, 1, 2, 3, and here I have some variable I can represent as a bar, b bar, and c bar, whereas capital Mi, which can be represented just like a plus b plus c. What is the difference between these two things? What I supposed to write
Make
mi
complement
and
of,
mi. These are equal with a complement to each other.
yes, sir, complement to each other.
Okay. Then a bar, b bar, c. It can represent as a plus b plus c bar because c is here is uncomplemented. One c is equal to 1, so it is uncomplemented. So 2 can be represented as 0, 1, 0. So 0, 1, and 0 in min term. In max term, wherever I have 0, I supposed to write uncomplemented way. Wherever there is 1, I should write in complemented way. Is it okay?
Yes, sir.
Now I'll create one bowl. M5. Okay, please find the max term of this. Select max term here from the board. So in between that, I can try to complete the remaining parts. So shall we stop? So what will be the right answer?
Option
Since
D.
it is option B.
B, sir.
D.
Yes, because here it is A, I supposed to write A bar. Here it is AND, I supposed to put R. Here it is B bar, I supposed to write B. Here it is AND, I supposed to put R. Here it is C, I supposed to put C bar. So option B, A bar plus B plus C bar is the valid answer for max term of M5. Okay, it's not a big problem. See, if it is initial level, it's okay, no problem. So in the further level, we can able to handle it. Okay. So what is the next point I want to emphasize here is I supposed to write this above expression. So F equal to A bar C bar plus A B bar C. Okay. So what is the product of sum here? If I want to write the product of sum, how can I supposed to write? We know that this is equal to summation term of M0, 1, M0, 2, 5. In the previous example, we start with 0 to 5. So what should be the this is a SOP format. In POS, what should be the F value will be? It should be pi cap
1, 3,
capital M1,
4.
4.
Yes, sir.
5, then 6 and
Input,
7.
6, 7.
7. Okay.
So
Okay.
there is 3 input variable. You have to consider every numbers up to the given numbers. Where the input number is minimum number is 3, so you're supposed to use 3 numbers, 3 logics. Well, so what is the equivalent value if you look it up? So let's write what is M1. M1 is
A bar, B bar, C.
no max terms. A plus B plus C bar. M3 is A plus B bar plus C bar, and M4 is A bar plus B plus C, and M6 is A bar plus B bar plus C, and M7 is A bar plus B bar plus C bar. How do I validate whether this is right answer or wrong answer? Is this expression, okay, let me write down, this is something called F1, which is equal to write this, and let me call this is F2. Is F1 is equal to F2? In the functional base, whether both are equal or not?
Yes, sir. They are equal. Just different forms.
They are in the different forms. So let me verify it also. So F1, F2, since it is just 3 variable, I can write ABC. And what are the minterms we are given? Let's take 2, 0, 2, and 5 alone, because for these 3 input combination, I suppose to get output as 1. For remaining case, I suppose to get answer as 0. If it's so, like example, what are the says? 1, 3, 4, 6, and 7. If I give this input, yeah, I want output as 0. Yes, somebody is unmuted and asked something. Shall I proceed? Yeah. So 0, 0, A, B, C is 0 means 0, 0, 0. If I apply here, what answer? A is 0, B is 0. It means A bar and B bar, C bar. It gives answer as 1.1. 1.1 gives answer is 1. So 1 or with anything, answer is 1. Am I right? So I get the answer as 1. Okay, likewise we can check with you. Please check with these two things. Okay, here I'm just choosing some other number. I just check the wrong cases like 4. 4 means 0, 100. If A equal to 0, A equal to 1, so 1 bar dot 0 bar plus A equal to 1 dot B equal to 0, 0 bar dot C equal to 0. So 0 dot anything?
0.
This gives 0. And see here also 1 bar. 1 bar means it comes to 0. So 0 dot anything? 0. So R of anything?
0.
For 4 I'm getting 0. Okay, let's try the same example in the same min term, first min term of 0 with max term. So here I'm supposed to put 0 or 0 or 0 bar. My answer is 0 plus 0 is 0. Yes,
1.
anyhow it gives answer as 1. 1 dot of 0 plus 0 bar plus 0 bar. Anyhow answer is
1.
1.
okay. Here also gives 1. So 0 plus 0 means 0 bar, here A bar. Then 0 plus 0. 0 plus 0 is 0, but no problem. But 0 bar gives answer as 1. Similarly, 0 bar answer as 1. Here also 0 bar answer as 1. So all the inputs are having 1. So answer is 1. Am I right? If it's okay, please thumbs up. Yeah. Now let's apply the same case with the other number, which is 4. Okay. 1 dot 0 dot 0, 1 plus 0 plus 0, 0 bar. Answer is
1.
1. 1 plus 0 bar plus 0 bar.
1.
1.
Again 1 and 1 bar plus 0 plus 0.
0.
0.
So 0 dot of anything.
0.
So even though in the product of sum, what is the specialty is that both are seems to be equal, but it's you feel that in the what is the difference is that in the sum of product, if at least one of the product term, if it is high, I get the output as high. Whereas in the product sum, if an expression is right expression and for the given input, it means that all the input, all the sum terms here, all the sum terms need to be high. Then only you will get the answer. So if you have the sum of the product and convert the product as sum, you get the exact answer. It means final conclusion is F1 is equal to F2. Any doubt in this club? Okay. So let me take this as the same example and proceed further. Okay, I'm just erasing these all the things, unknown things. I hope you understand these particular things are same. Okay, so I'll just take this expression and try to bring up with the above expression. What is the way is A bar, C bar, R with A, B, C. Can I convert to SOP to POS? Distributed law. For understanding purpose, I think I can assume this alone as X term. Let's say X equal to A bar, C bar. So it comes X plus A, B bar, C bar. A, B bar, C. Am I right? This is equal to what? X plus A times of X plus B bar times of X plus C. Am I right? Yeah. Now apply X here. A bar, C bar plus A bar, C bar plus B bar, A bar, C bar plus C. Is it okay? I'm just simply reapplying back. Okay. Now that gives A bar plus A is 1. Then C bar plus A. This gives A bar plus B bar times of B bar plus C bar. Is it okay? And finally, A bar plus C. C bar plus C is 1, so I'm calculating. Is it okay? Is this both are, if I call this is G, and whether G is equal to your F1, how can I compare it? This is what form? This is canonical representation, whereas this is simplified form of POS. Okay, so if you cross check this, both are same. What is the way it is? I'll just tell you in another example, another page. Let me write that G is equal to, so far it's okay, right, everyone? Yeah, so I can write, let me label as usual, A first plus C bar times of A bar plus B bar times of B bar plus C bar times of A bar plus C. Is it okay? I'm rewriting the same expression. So in this case, I supposed to add on some unknown elements by 0. Here there is one unknown element is there, so I'm adding 0 in order to maintain the same elements. I mean, expression need to be maintainable. Is it okay? By adding 0 is not problem, right? And here I'm doing add operation. In the previous case, I'm in the AND operation. I'm just adding with B plus B bar. Here I supposed to put with B bar B dot B bar, which use what? B dot B bar is X dot X bar is
0.
So I can include here. Here the missing term is C, so I put C bar. Okay. Here A term is missing, A dot A bar. Here B term is missing, B bar. Is it okay? Yeah. And then I can re-expand it like this is equal to A plus B plus C bar times of A plus B bar plus C bar. Is it first one is expanded like this two way? Is it okay? Are you getting any confusion? If it's so, I can rewrite the same thing like let y equal to A plus C bar. So this is equal to y plus B bar. Am I right? I can write like y plus B times of y plus B bar. What is y? Y is A bar plus C bar. So A plus C bar plus B. Then A plus C bar plus B bar, and rearrange it. I can get A plus B plus C bar. A plus B bar plus C bar. Is it okay? Yeah. Shall I erase this part? I'm just deleting this one. I'm continuing it with a complete expression. This gives A bar plus B plus C. I think it was B bar. Then A bar plus B bar plus C bar. Then A plus B bar plus C bar. Then A bar plus B bar plus C bar. And last one gives A bar plus B plus C bar, A bar plus B plus C times of A bar plus B bar plus C. Okay. So number of sum terms are 1, 2, 3, 4, 5, 6, 7, 8. And let's compare with that way in this case. But here I have only 5 terms. But here I have number of terms more. Some terms are more. Is it same or is there any mistake? Compare it. Let's
thing.
compare it. Same thing, right? But if you are, still this is quite complication to compare. There is any duplication on it. So what is this is equal to in terms of m? I can call as 0, 0, 1 in terms of max term. 0, 0, 1 is m1. Okay.
Yes, sir.
Dot times of, because there is a dot gate, then 0, 1, 1. Am I right? 0, 1, 1 means I am telling 0 because I am talking about max term. Normally in the min term I tell 1, 0, 0. Normally in the min term I am supposed to tell 1, 0, 0. In the max term I am telling 0, 1, 1. Wherever there is uncomplemented I am supposed to put as 0 for max terms for easy understanding. Okay. Well, this is again I write it as 0 or 1 1 0. Am I right? Then this is 0 0 0 is M7. Then this one is can you please tell me what is this min term or max term?
M3.
211.
M3, which is already there.
Yes,
So
sir.
it is redundant. And what about this one?
Same M7.
M7 is already there. So it is again redundant. Then this one,
4. M4.
M4 is not there. So let me put M4. This one is
M6.
M6 is already there. So again this is redundant. That's it. So I finally conclude with 5 terms. And let me rearrange this M1 dot M3 dot M4 dot M6 dot M7, which we told in the previous case. Yes. For this is a max term. Is it okay? So any doubt in this regard? Well, again I will put some things. M1, okay, let's M3. So which are not adjacent? Select it. I am talking about sum terms, that is max terms. Okay, fine. Did you identify it? Please give your answers in the poll. Till then, I just do other work. Wait, maybe please omit this part. It's not up to our topic. Okay, fine. Have you identified the answer? Okay, let us discuss about that point. Okay, what is m naught? Sorry, m1 is equal to 0, 0, 1, 0, 0, 1, and m2 equal to 0, 1, 0, and m3 equal to 0, 1, 1, and m6 equal to 1, 1, 0. So when you compare these things, it is not so. Comparing these two things, these are adjacent. Comparing these two things, these are not adjacent. Okay, so m1 is adjacent with m3. Okay, whereas m2 is, whether m2 and m3 are adjacent.
Yes, sir.
M2 and M3 are adjacent. M2 and M6,
Yes, sir.
that are also adjacent. Then M3 and M6,
Not adjacent.
No, no, sir.
so M3 and M6 are not adjacent. Okay, so in this case, I can, because anyhow M6 is joined with M2, M3 is joined with M1. So mostly it has some pair. If I have represent with three variables of M1, M2, M3, and M6 with three literals, there is a possibility of reducing one literal. So it is as some adjacent cells. But in other aspect, M2, if I have M2 duplication of, if I have 2 times of M2, this can make to reduce more number of letters. So M2 can be joined with M3, I get one reduction. M2 again joined with M6, I get another reduction. So what it may do times, it means that if I have M1 dot M2 dot M3 dot M6, I can simply again multiply with and with M2. Is there any change in your application? Or is the functionality just changes?
It's the same.
Same functionality, because I will know that and of A2 elements of same element will give same element only. So by the way, I can able to group these two things together and these two things together, and finally I will reduce 1 literals from each terms. Alright, and if you want, you can connect this M1 and M3 separately if you want, but this alone is right now standalone, right? How many literals you have in the M1? Basically 3 elements, A plus B plus C bar. What's supposed to do so that it can, this also reduced by 1 literal? Can I multiply M and with one M3 again? This one and this one are duplicate. Even though it is duplicate, this makes to reduce 1 literal. Okay. I think I was 0, 1, 2, 3. I think I supposed to put M4. If I insert M4, can you check what is M4 will be? M4 is 100. Is it 100 is adjacent with anything?
Yes, sir. M3.
M4 is adjacent with M3?
Yes, sir.
Again, look, check and tell me. M4 is A bar plus B plus C, and M3 is A plus B bar plus C bar. How many bits are varying?
All 3 bits are, so this.
3 bits, so it is not at all adjacent. Don't say adjacent means 3 after 4 is adjacent. That all not adjacent. That should be a single bit variation in binary tree. So it's alternately called as a gray code. You should have the gray code represented. So 0 is adjacent with 1 is adjacent with 0, and 1 is adjacent with also adjacent with 3, and 3 is adjacent with 1 as well as adjacent with 2, and 0 is also adjacent with 4, and 5 is adjacent with 4 and 1, and as well as 7 is adjacent with 6 and 3 and 5 and 6, and 6 is adjacent with 2 and 7. Okay, these are the possible adjacent combination. Whether 1 and 7 are adjacent? No, 1 and 7 are not adjacent. Let me mark in that color. 1 and 7 are not. Similarly, 5 and 6, 0 are not. 5 and 3, no. 7 and 1, not at all possible. 1 and 7 and 2, not at all possible. 6 and 3, not at all possible. Please check that one. Okay. Any question? Yeah. So I'll just add on some more for your understanding purpose. Okay. I'll just talk with small min terms. Okay. Fine. Please find the adjacent cell for this min term M48. And before that, you just tell me how many bits are required to represent this term. It's okay. How many bits are required? How many input lines are required? Answers in the comment, in the chat window. 6 variables. Super. So represent all the minterms given in the option, represent all the minterms, and also represent number 48, M48, and tell me which binary value of 48 having only 1 bit variation with the remaining cases. Remaining options.
Sir, could you repeat the question?
Question is, we supposed to, I hope you know this particular M48 axis number is 56, so it has supposed to represent with 6 variables, 6 input or 6 input variables, right? So you please write that min term in binary format. M48 is represented with 6 bits. Likewise, 16, 47, 40, 56, all 4 options in 6 bit definition. Then compare that 48 with 16, 48 with 47, 40 and 56. If any cases, what are the cases are adjacent to each other?
Okay, sir.
So 48 is adjacent to which cell? also for this next example. So the point is, purpose of asking this question is, you're supposed to identify. Have to practice with the big numbers. That's my motive for this particular task. Well, one answer is I have received one answer. I think, are you getting the answers? I hope nobody can able to see their answers, right?
No, sir.
Show the, yeah, maybe I can show the result for previous cases. Okay, I think I can show the answer. Only two guys are show a result. Which one will be right answer? 16 or 40? So what is the binary value of M48? It is 110000. Am I right?
Yes, sir.
Then what is M16, which is equal to 010000? Then M40, which is equal to 101000. Am I right? M56 is equal to 111000. 47, I forgot. Yeah, maybe I can write 47. What 47 is 101111. So compare with this true number, how many bits are varying? 1 bit.
Only one.
Okay, and of course this first itself we can identify this is adjacent. Okay, let's check it out. And these two things, how many bits are varying?
2, sir.
2 bit. These 2 bits
Second
are
and third.
varying. Yeah, so this is not adjacent. Compare with these two things.
They are adjacent. Only the third one is varying.
They are adjacent. 56 is also the valid answer. Well, but last one is about 1, 2, 3, 4, 5. 5 bits are varying, so it's not at all adjacent. Okay. So 16 and 56 are the valid answer. Okay. Can you please compare with the next example, which is not adjacent? Of 4 main terms, which are the things are not adjacent? Okay, what is the answer for the last poll? Can you please put your answer? Find the non-adjacent minterms. Are you guys? I mean, all of you guys are trying this? All are trying? Yeah. Good. One note is there. Similarly, I want the remaining ways. Please try to apply answer. Try to find the answer. Okay, maybe I can write that. I mean, 62. 62 is 111 and 54 is 110 46
101110
101 110 and 61.
111101.
Yeah. So I hope these three numbers, mostly first these set of numbers are equivalent, and here with this compared with these two things adjacent, and with these two things these are adjacent. Okay, so it has some adjacent element, whereas this only has no adjacent to anything. It is separately there. It's not connected with anything.
Sir,
So
61.
answer 61 is a non-adjacent, and it is a essential prime implicant.
Yes, sir.
Okay. Yeah. So I think we have done most of the process, and I hope from the beginning we have started with understanding of min term, max term, and then finally we started with canonical representation of min term and max terms, and so on. Any doubt in this regard? If not, I will proceed further. Yeah, fine. So I suppose I'm telling you that this is the expression. Okay, let A B bar plus A bar B. Or else a function of A comma B comma C, which is equal to B C bar plus A bar C bar B bar C. Please write the canonical. What are the min terms in B? Can you please tell the Boolean function of these things in terms of A, B, C? Is all are working? If yes, maybe I can continue. Otherwise, if you want the answer, I can start proceeding. So I was supposed to start with 1 dot of B C bar plus 1 dot of B bar C. Expand it. With A plus A bar times of B C bar plus A plus A bar times of B bar C. Just give me 1 minute. Let me put charger in front. Okay, fine. Have you find the bin terms? This can be expanded as a b bar c bar plus a bar b c bar from these two terms. And by these things, I can get a b bar c plus a bar b bar c. Am I right? And finally, you can tell that this is equal to what? M6 or M2 or M5 or M1. Am I right? So 1, 2, 5, 6. Somewhat elongated way of writing, right? Shall we do the some simple way? Shall we try to do the same thing in simple way? It's just not a approach, but I'm doing this way. Is for easy calculation, for fastest operation. Shall we do it or you wish? Yeah. So here the bin term is B C bar. Another bin term is B bar C. Anyhow, I want to include both the things. So B is 1, C is 0. B is 0, C is 1. Remaining thing is don't know. Remaining variable is only one variable that I don't know. That I don't know can be represented as either 0 or 1. And two things will be fixed constantly. So this is be 0, 1 and remaining two things are fixed at 0, 1. So this is equal to what? 2, 1, 6 and 5. Okay. I'll just try to give the same problem in higher cases so that we can understand that. Okay, let's this. Okay, now how can you do? You have to do the same approach like this, like 1 times of b c bar dot 1 plus b 1 times of b bar c dot 1, and this can be written as a plus a bar dot b c bar times of d plus d bar plus this one can be written as a plus a bar times of b bar c times of d plus d bar. So we supposed to keep on doing so, find out these things, right? Anyhow, we get some answer. Let's cross check first. So this is equal to a b c bar plus a bar b c bar times of d plus d bar. Okay, this part is over. Plus again this I expanded it. I'll get a b bar c plus a bar b bar c times of d plus d bar. Again expand it, you'll get this one expanded with the d terms, you get a b c bar d plus a bar b c bar d. Similarly, product with these things, you will get a b c bar d bar or a bar b c bar d bar. Okay, so far okay for left side. Or with the remaining things, what is the answer we may get? Can you anyone unmute and tell? A b bar c d plus a b bar c d bar. This is ANDed with these two things. Is it okay? Same thing, I suppose to process with these things, you will get a bar b bar c times of d plus a bar b bar c times d bar. Right? Too much of process. So that gives min terms like, what is this one? This is equal to what?
2, 3, 4, 5, 11.
Are you saying, is it 2? 1101.
Okay, I'm. Okay.
13.
Okay.
Okay. Oh, you are telling you have finished this answer.
Yeah. So by your
Yeah.
method, the other method which you showed.
Yes. Okay. Cool. So anyhow, I'm going to do that other method. M1 and this one gives M12 plus this one gives M4 and this one is 8, 10, 11, M11 and this one is M10 plus M3 plus M2.
Sir, is the second
Right.
one M5 or M1, sir? The second one.
This one?
The second term, is it M after M13? Is it M5 or M1?
M1.
Sir,
Oh, you are
M1,
asking. Yeah,
M1
sorry. M5.
M1 is not there.
M5. Yeah, thanks. Yes, it's M5. I just 0101. It's M5.
Yes, sir. 0 1 0.
Yeah, thanks for giving that way. So this is somewhat extended phase. So if I do the same process for 5 variable, 6 variable, or n number of variable, maybe I can do the same procedure, but somewhat time consuming. But I will just tell you the same again the same approach. So these two terms are constant. So it is 1 0 0 1. Similarly, I don't have remaining two elements like A and D. So A and D can be as two input. I have 4 combination. So A will be 0, D will be 0. A will be 0, D will be 1. A will be 1, D will be 0, and both are 1. Whereas B and C are remains constant. Similarly for here 0 0 0 1 1 0 1 1, and B and C are remains constant. Okay. So on this process, you will get M4, summation of M4, 2, 5, 3, 12, 10, 13, and 11. Matter of 1 minute, not even matter of 1 minute. Okay. Let's do the same process. BC bar plus B bar C. It's a function of A, B, C. Okay. Please tell me the answer of canonical representation of SOP. I just want the answer in SOP. Sorry, POS. And also in canonical representation. What will be there?
Multiplied by A plus A and D plus D.
So you're supposed to do 1 dot of B dot C bar. No, first of all, okay, fine. Better way is you convert this thing to first POS, because I want POS, right? So what is the way? B plus B bar times of B plus C times of B bar plus C bar times of C plus C bar. Okay. But this is not a canonical form, but it is a POS form. Is it okay? Now this 2 is not necessary. So B plus C times of B bar plus C bar. So here the only 2 terms are missing. Well, 1 terms are missing. I'm adding 1 term with 0. And that 0 is A bar plus B plus C. A bar plus B bar plus C bar. This gives what? A plus B plus C times A bar plus B plus C, A plus B bar plus C bar, then A bar plus B bar plus C bar. Is it fine? How I written this? A is processed with these things and B bar is processed with these things. Distributed. But already we discussed this one method. If I know the function A, B, C in summation of M, we already defined it, right? What are the values we got? M1, 1, 2, 5, 6. M1, 2, 5, 6. If I want product of sum, this is capital M of 0, 3, 4, and 7. This is the other equivalent way, right? What are the terms are there? Missing terms will be act as a canonical product of sum. Since already we defined it, we derived it. But and also this is quite easy to find it out. Compared to this is not too much effective for us because we are regularly using the SOP format, not POS format. That's why I'm doing. But it's not true. If you all from the beginning itself you keep on working with POS format, that people will understand that POS is a very simplified method compared to SOP. But mostly we are dying with most of the problem. Even in the outside world, we look at all the things. Maximum we'll just run with the SOP format. That's why this way is quite easy to find a canonical form of Boolean expression SOP format. Then you can write the missing term of this some SOP format that are the canonical form of POS. So 0 means all should be 1. This is M0. And this one is 100 is 4. 011 is 3. 111 means M7. Okay. Any doubt in this regard? Yes. Shall I move on? Everyone is okay with this? I need thumbs up for everyone if it is okay and can proceed further. Okay. Well, can you please tell me what is the canonical form of the same expression? A, B, C, D of B, C bar. Why you again? B, X, or C in POS form of canonical form of POS.
Sir, a canonical form of which term?
Same B plus C bar, B XOR C bar. But I am telling that B and C bar, B and T term expression. This particular expression is depends on 4 variables.
Okay.
Initially, I told you 3 variables. You got these terms, but now it is 4 variables. So this is already be determined. So the product term must be zero comma 1, 2, 3, 2 and 3 are there, 4 is there, 5 is there, 6 is not there, 7 is not there, 8, 9 is not there, 10, 11 is there, 12 is there, 13 is there, 14 is there, not there, 15 is not there, 16 is not there, 17 is not, 18, 19. Is it right? Hello. I'm sorry, my data is over. That's why it's so. I hope you are doing that work. Have you completed that work, or do you have any doubt in this regard? Is my voice is audible for everyone?
Yes, sir.
Yeah, and okay, fine. I hope you are doing that
Yes,
problem.
sir.
It's quite simple and straightforward, right?
Yes, sir.
Yeah. So is there anything else you want to discuss from this week content? And mostly these are the things only we are going to handle it. So sometimes we'll ask a canonical form of SOP, POS format and a canonical form of SOP format, or simplified form of SOP and simplified form of POS. So this is a way, and I hope you are aware about the min terms and max term, very much clear about it. Is it right for all? If I have any question or doubt regarding the min term explanation process and max term process, representation of min term and max term. If everybody is okay, can you please thumbs up? Okay, about 49 people, only one has thumbs up. Remaining guys, yeah.
So we'll need to practice it by our own selves so that we become comfortable with it. Because
Of course, more practice by yourself is very important than this. I'm just giving some idea about how to handle fastly. That's fine.
Yes, sir.
And please try to solve some of the activity problems. That may be the same problem we're going to coin with the fifth unit also. Same kind of problems. We're going to do the same problem next week also. Okay. And I think I can do with one more term so that I can wind up ourselves. Maybe I can choose, one of the problem of that particular activity problem. This is one of the activity problem. Let us try to handle it. Equal to A bar, B bar, C bar, D bar plus A bar, B bar, C bar, D plus A bar, B bar, C, D bar plus A, B bar, C, D plus A bar, B, C bar, D plus. So what is a simplified format? So I'm getting the answer as something like A bar C. This is a simplified version of it. Can you tell me what are the redundant elements need to be used so that we get these answers?
B and D.
Yeah, this will be the final most answer. Can you try with this?
Yes, sir. First two we can take A complement, B complement, C complement common from first two term.
Okay.
And then A complement and B complement from third and last.
Third and last.
No, sir.
No. Why don't you try the same thing with this?
It's a third and fourth one we can take A bar and B bar.
Yes, this will be complement to each other because they are adjacent. And here this one. So as you mentioned, first and second, if you take it up, you get the answer as A bar, B bar, C bar, and third and
fourth, A bar and B bar.
Third and fourth, we take means A bar, B bar, C will be the common term. So this is reduced from here. A bar, B, D. Am I right?
Yes, sir. A bar and B, D from.
Okay, but here there is some D term is it, but in my expression I don't have D term. But anyhow, we get the answer. That's not a problem. That is also an answer. But this is having very less number. I have A bar C as a final answer.
Then, sir, we can take second and fifth one, A bar and C bar as a common. Then D might get cancelled.
Second and
Fifth,
last one. Fifth one, this
fifth,
one.
yes.
Okay. But anyhow, this term is there, right? How bad? Where are you going to connect with? Everything is relative. And okay, let's try to proceed it so that we can try to simplify it if possible. Then from here I can take A bar, B bar common, then reduce A bar, B, T from these two things. Ultimately C is cancelled. I think whether my answer is right or wrong, let me check. Maybe I'll just try to cross check whether the answer is first correct or wrong. Maybe you can understand this method in the next week onwards. This is Karnaugh map. I'm just verifying only, that's why A, B, C, D. So A bar, B bar, C bar, D, and A bar, B, C, D. This is 1, 0, 0, 1, 0, 0, 0, 1, 1, then 1, 0, 1, 0, 1. Okay. If I connect these things, I'll get answer as A bar D plus A bar B bar. I think a strong answer. I think this is not the valid answer, I think. I think instead of 5, I supposed to enter a 6. If this number is not like this, if this is instead of bar, if I have like this, then there is a chance of C get cancelled and I will get the answer as A bar plus C. Is it okay? No, it is C, right? This one. Yeah. If the bar is here, your answer will be right. This will be the right answer. For the now, as per the anyhow, I should not get the answer as C. I will get the answer as A bar C. A bar B bar plus A bar C. Taking A bar common, B bar plus D here in this case, or this will come in this format, A bar of B bar plus C, like this. Okay, anyhow, you will get the answer either like this way This is not the right answer. A bar D plus A bar B bar. This will be a simplified expression. Okay. Any doubt in this particular parts or any other things you want to discuss from the previous 6 sessions? We can discuss now. This is the time for us to discuss.
Sir, I had a question regarding 2's complement.
Yeah, what is it?
Like when we are doing an operation using 2's complement, both the numbers should be in the 2's complement format, right?
But
Let's say
I
when we
don't
are
understand the actual question. Why you are doing operation of 2's complement?
like we are saying we want to subtract a number.
Okay.
So let's say we are doing 3 minus 2.
Okay.
So then the number which we are subtracting has to, since it's minus 2, we have to have minus 2 in the 2's complement format, as well as
3 minus 2, which is equal to that of 3 plus of minus 2. Is it okay?
Yes, sir.
Okay. What is the binary equivalent? Okay. Now let me define. This is negative signed number. This operation looks like a signed operation, right?
Right, sir.
Okay, so what type of signed operation, signed representation you want to do? So either I'm using for better arithmetic operation, whether 2's complement is suitable or one signed binary format is suitable. Which one is suitable? I already discussed.
2's complement.
Which one is complement? In which type of? So if you represent your binary number in 2's complement, is good. So this is plus 3. So plus 3 can be represented 2's complement by 0 is the most significant. Right now I'm using with a 3-bit variable. Okay, because 3 and 2 can be accommodated with the 3-bit itself in signed number. 3 can be represented in 2-bit number, 3-bit number. 3 can be represented 3-bit number, and minus 2 also can be represented 3-bit number. It can be accommodated. So 3 can be represented as 0, 1, 1, which is equal to minus 0 into 2 power 2 plus 1 into 2 power 1 plus 1 into 2 power 0. It gives 3 only. So no issue at all. So this is 2's complement representation. I'm not doing operation of 2's complement. I'm representing with this formula.
Right.
Okay. Now again the same thing. Minus 2 you please represent in 2's complement formula. So minus 2 can be represented as minus, yeah, this is will be
minus 3 plus 1. So 1 0 1.
1 1 0.
1 1 1.
Minus, this is minus 4 plus 2. This question is plus 2. That gives equivalent value as minus 2.
Sorry.
Okay.
Yeah.
Now I'm not doing inversion operation, but most of the people, okay, so far I'm not doing any inversion operation. I'm just simply represent the minus 2 in the respective value, plus 3 in respect to 2's common representation, nothing. So in the plus 2 in the positive numbers are similar to that of normal binary number, whereas minus number will be having the most significant bit is 1 and the respective position having corresponding weight value in the 2's common representation. Whereas in the signed binary representation, there is no change of weights. The weight value of plus value is equal to that of minus value, except the most significant bit alone gets asserted by 1 in the signed representation. Here there is not so. Each and every bit position has respective weight to represent in the equivalent decimal value.
Right.
This is having minus 2 power or plus 2 plus 0. Like this, I'm keep on adding them. That gives the equivalent value of minus 2.
Right.
Well, I'm not doing by 2's complement operation. So you are thinking like 2's complement operation is some binary number. If I do operation of inverting,
Right.
I use one output that is called as 1's complement operation. Please
Right.
add 1. Then you're telling that it is a 2's complement. And
Right.
what is the representation is this? If I do this kind of operation, like this,
Right.
it's telling that I'm getting binary number. Or opposite way, if I do it means binary number, negative binary number gives positive binary number.
Okay.
Let us take the same case. So I want minus 2 here. So for that case, let me take the plus 2 here. What is plus 2? 0 0 0 1 0.
Right.
Minus 2 is 1 1 0. Let's take inversion 1 0, 1, adding with 1, which is comes to 2's complement, 0 complement 1. Both are similar. Okay.
Right.
Please, if you are doing operation based, mean it will get confused.
So then
But
we
to
need
clear understand, yeah.
we need to like if someone says to me that represent say 128 in 2's complement method, then I'll need 9 bits to represent that, because
Are you
and
sure 9 bit is 9 bit is required.
right, but 127 120 let's say 9 bits. Okay, it can't be done like the 2's complement operation can't be done in 8 bits, right? But if I say okay, I'm getting confused here.
Okay, maybe if my understanding is right, I'll just tell you. So let me take 2-bit number. What is the range of 2-bit number, signed number?
Signed number is -2 to 1
Plus 1.
plus 1, right?
Okay, that is 1 0, -1 is 1 1, then 0 is 00, then 0 1 is plus 1. Then 3-bit means minus 8 to
7
plus 7.
plus 7,
And 4-bit is minus
16 to
16 to plus 15. Then like this.
Minus
So
16
8-bit
plus-
means. Sorry, I think I was wrong. This is 4 to plus 3. This is minus 8 to plus 7. Thanks for reminding me.
right?
So totally 16 states. Minus 8 to plus 7, 16 states. This gives totally 8 states only. This gives only 4 states. 2 bits can have 4 states. 8 bit can have 256 states. So what are the numbers? Minus 128 to 1 plus 127.
7.
So in this case, if I give the binary number is 128, it is not within the range of 8 bits. So you're supposed to go with 9 bits.
Right.
Okay, what is that 128 will be in 9 bits? Normal binary 128 is 10000000.
Right. Right. But in 2's complement, it will be 1.
This is extra.
Okay.
9 bit. I am supposed to put in 9 bit.
Right. Okay.
So this is equal to what? Minus 0 into 2 power 9 plus 1 into 2 power 8 plus 0 into anything will be 0. Finally, it gives 128.
Okay.
Okay. Then if I consider with 8-bit case, let us take with 8-bit. 8-bit in the case, if I just omit this part, last bit 0 0 0 0 0 0 0. I have only 8-bit. So this is equal to minus 1 into 2 power 8 because I 2 power 7. Sorry, am I right? This should be 8, right? This should be
Right.
7. I'm sorry. Okay, so this is some of the bit portion. Actually, I forgot to, but anyhow, the answer is comes right. So my 2 minus 1 into 2 power 7 plus 0 into 2 power 6 plus 0 into 2 power 5, 4, 3, 2, like this. Everything will add to 0. So this is again equal to what? Minus 128, which is the most lowest smallest number in 8-bit in this case.
Okay.
But if you're willing to represent in 8-bit, please remember, if you do this kind of 2's complement operation, you must be aware about the range of number.
Right.
Because we know we already told that 1 bit is used for sign bit and remaining bit is used for data bit.
Right.
Okay, so
Right.
if I ask for minus 120 plus 128, okay, how do you represent 128 normally?
It will be 2 raised to 8. The 8 bits. 1 0 0
It
0
need
0.
1 8 like this.
Right. But
But
this is not
what is the signed bit?
complement.
If I consider this is, if it is ninth, if this is the most significant bit, it is 1. It refers to negative number. But I given as positive number only. So it means I want to maintain the positivity, so I'll put 0.
Okay.
Now it is becomes 9-bit representation which is plus 128. Yeah, what's the question?
Okay. So if someone says to me that do an operation using 2's complement and 128 is involved, says use 8 bits, then I can say that it is not possible to do that.
Of course.
Because I'll need. Okay. That's
Exactly.
what I.
represent in, well, okay, I'll just ask the same kind of question. Please represent 128 2's complement representation in 8-bit. Is it possible or not?
No, sir, not possible.
That's it. That's it. If
Okay.
you are aware about the range of bits, so we can easily understand. That's it. Representation quite easy for it.
Okay, sir. Okay, that was the
Yeah.
point of confusion. Okay.
Sir, I had a
Okay.
confusion in week 2 graded assignment in question number 2.
Okay, just give me 1 minute. I'll open that part. Question number 2.
Yes, sir.
Okay, the given number is 10101101. What is its equivalent value?
Actually, in the first question, the answer is that the data given is insufficient. So in this question, it depends if the given binary number is a unsigned representation or a 2's complement representation.
That's
So
what
there
I
will be
given
only
3
one
options.
correct option, right?
No, 3 correct options. See, I'm telling you, this is equal. If I represent in 2's complement representation, this binary number is a signed number, okay, or some binary number. If I think it is a 2's complement represented number, it means this must be signed number. Right? If I represent this is a
But
2's
sir,
complement
I
representation.
need to know how many bits are being used for that.
Yes, this is a given bit. This is a given binary bit. With this given
Then
binary
in
bit,
the
it's
then in the
proportional.
first question, if I take the given number as the given number of bits, then
Yeah.
also the data is not insufficient. The data is given there, right? So can
So
I
in the previous question,
in
yeah,
the
one
previous
second.
question number 1,
Question number 1 defines how many. I mean, what are the? 1111 is what? Right?
yes,
Okay. 1111 is a largest binary negative number. It's not a positive number. If I consider it as a signed 2's complement representation, or else it is a largest positive number. If I think it is a positive number or binary number. See, I have 1111, which is equal to -1 in 2's complement representation. Similarly, it is equal to plus 15 in unsigned number. Which is correct?
yes, sir. Okay, sir. Can I show you my solution? If
Yeah,
you can
please.
read that part.
You start sharing.
Okay.
I think today's session is over. If you want continue, please wait. Otherwise, you can proceed with yourself.
Sir, can you see the first and the second question?
Yes, I
And
can see.
read.
But if it is unsigned binary representation, then so okay. What is your point?
Because of the first question, the second question should also be the only one correct option, right? Because the language given in
Why
the
you are
second
connected
question is the
the
given the binary number this. So the number
okay.
of bits is not given.
Okay.
In the first question also, because the number of bits are not given, that's why the data is insufficient. Otherwise,
Okay.
data is sufficient.
Okay, but data is insufficient because I'm not giving you an exact option. Maybe I can tell this is the largest positive number when it is a binary unsigned number, or largest negative number when it is a 2's complement representation, or smallest negative number if I represent in signed matter representation. Am I right?
Yes, sir.
3 answers are right answer.
Yes.
Okay.
Yeah, in the first question,
If I
right?
explicitly, in the first question, 3 answers are valid. with respect to the different type of representation, which is not mentioned in the options also, but I simply told it is a smallest negative number, largest negative number, smallest positive number. It is giving ambiguity. It doesn't
Yes,
say
sir.
which type of representation I used for. So that's why I told you the last option, which is insufficient information. Okay, insufficient information in sense I can't able to predict the given number. This is a positive number or negative number on the overall abstract level of abstract. Whereas in the second option, let us look at the second option, second question. Yeah, in the second question, what happens? I told you this is a binary number. It may be, it is actually, we calculated it. Maybe you can get the negative minus, that is 83, minus 83. If you are representing 2's complement representation.
Yes.
Or else, if I think all the bits, 8-bit is positive number, there is no signed bit at all. This means it is all an unsigned bit, then it is equal to that of 173.
Yes, sir, I get that.
Yeah, and this one is equal, this particular set I consider as a magnitude means is a 45, and since it is 1, it is a negative 45 in 1's complement representation or signed magnitude representation, and final option is not valid in this case.
Sir, can you tell me one thing that for the question number 1, what information is not given?
Yeah, what information is given is that the given number is 1111. What is the decimal equivalent? I give the option is option A is smallest negative number. Smallest negative number is okay, but what type of smallest negative number? I didn't explain that smallest negative number is 2's complement smallest negative number.
Okay.
Whereas in the option 2, I mentioned explicitly minus 83 in 2's complement representation. That's
yes, sir, I get it.
Yeah.
Thank you, sir.
Sorry, if this terms makes this kind of ambiguity, means I'm extremely sorry for that. But anyhow, I hope the question doesn't give ambiguity. Options also gives the values. Maybe some kind of confusion may arises. That is obviously happens. But I don't want you to repeat.
No,
the
sir.
same thing in your
Actually, it's fine. I think we need much more maturity to understand this type of question.
Yeah. Thank you. So, well, any questions?
Sir, question number 13, week 2, graded.
1 second. Let me close all the polls. And for all those who are participated, really thanks a lot. Okay, what's the question number? 313?
Yes, sir.
Yeah. What's your problem? Oh, you have to solve it.
Yes, sir.
How to proceed it? I hope. Can anyone give the solution?
Yes, sir. The grade assignment solutions are uploaded already.
Exactly. So it is x minus 3 times of x plus 6. X minus 6. This is the solutions which is equal to that of this, but this is not represented in binary format. It is some other number system. It's not decimal number system. This equation is represented in some other number system, whereas solution gives in decimal number system. In such a case, we can have the answer like x square minus 9x plus 18 is equal to 0.
So the numbers used at 11 and 22 are in other bases, right? Not in
other
decimal.
bases. Exactly. So 11 can be represented as 1 times of b1. B is a base value plus 1, which is equal to 9. So the base is equal to 8. Even you can do the same thing. 2 power base 1 plus 2 power base 0, which is 22. I am representing like this, converting it to the decimal number, which is equal to 18. So 2 to the base equal to 18 minus 2, which gives 16, which is again 8.
Sir, but it's confusing that x is also a number, right? So which base is it in?
No, because the default value is at decimal place, you have to consider it as the default is 10. So when you're converting it, you have to take it in forms of 10. So 22 will be 2 into 10 plus 2. So it will be 2 into b plus 2.
Yeah, but point is this is either decimal or not a decimal. Your question is this one?
Yes, sir. X, the
yes, of course.
values
Something
of
is, yeah, just determine the base of the solution such that the solutions are equal to the given quadratic equation I mentioned. It means this is not a known base. This is the known base of decimal.
Okay, sir. Okay, got it.
That's what. Yeah. Okay. Thanks for all patient hearing. We can meet you on the next live session again. Once again, everyone, thanks
Thank
for
you,
everyone
sir.
for giving your valuable outputs. I mean, attend the activities which you are attending very well. Thanks a lot. Okay, see you all.
Thank you, sir.
Goodbye,
Thank
sir.
you. Thank you. Goodbye.
Thank you, sir.
Thank you, sir.
Thank you. Thank you.